Yeah, let's make this 3. What do you mean, what is this? And certainly, what do you mean with I'm dead? Dead people cannot type. This is the number of consecutive. How do you write that? Consecutive. It's actually a group. Should use a group index, I think. Group index. Group index is just an index into an array that stores groups. I mean, more precisely, it is a wrapper around the size type. Around an int, actually, not a size type. So it's just an integer, but then wrapped, protected, private, and you can only access it through all the operators that exist. Then that type is then only allowed as index into an array of a type that says that it accepts group indexes. So it's just an int, but specifically an int that tells me which group it is. Yeah, but that's the, Tom, that's the implementation. I think that more important, for me at least, for the programmer, is that you see it as I would say almost a pointer or an ID of specifically a group. I also have a group type. And a group is, in this case, a set of elements. An element, and so on. You have to be a bit into it, I guess. Okay, so this whole thing came from tube file that I created earlier today. So this is these are all the possible partitions that you can make with 5 elements. And I listed them as the group that each element goes into. So we have 5 elements. I named the elements A, B, C, D, and E. And therefore we have a maximum of 5 groups, namely 0, 1, 2, 3, and 4. And here you can see which group each element is in. So element A is always in group 0, and then element B can be in group 0 to, well, actually till 1. It never is in group 2. No, not, sorry, I meant set, not a mathematical group. Maybe you're right, I should have called it, I mean, now I'm having a class called group, but I should have said set if I was thinking about mathematics a bit more. It's a set. So we're partitioning these elements into sets. Or into cliques, where a clique comes from graph theory. So a clique would be a complete subset of the graph, but then it's also a set. Anyway, we're talking about a sub-problem now. So the problem here is to get back these values, these group indexes, 0, 1, 2, 3, and 4 in this last case, from the index in the beginning. So I have 51, I want to get 0, 1, 2, 3, and 4 out of it. And I have 23, I want to get 0, 1, 0, 2, 2 back out of it. Now the fact that both A and C have both are both 0, that just means that they are in the same set. And then we have a set with index 1, which just contains B, and then we have a set with index 2, which contains D and E. There is no ordering within the set. So this is a way to partition 5 elements. And I just encode it with the group, the set numbers that they are in. If it's okay with you, I'll continue calling it the group, because that's what my class is being called. Now, in order to get the finger behind this, I just count the number of times that C is, or C or B or whatever, is has the same value. This C is in group 0, and then again and again and again and again. That's 5 times on a row. Okay, so if this represents C, element C, then the group is 5 times on a row. So that would be 5, and this is then, well, 0 it was. Now I'm not 100% sure, but why not also include the element that we're talking about? Because both the group and the count are very specific for a given element. It can be derived from the context, but might as well store it. Might come in handy to just know what the element is. So let's store the element here in here as well. But even that is not enough context. There's more context. required. So this would just be, yeah, well, some of the context, but not all of it. So then it makes it a bit dubious if it's really important to store it here. Yep. Okay, that's a constructor. Now I have more information, namely a vector with 3 objects. But the index is a group. So I'm not using standard vector, I'm using utils vector. And then it compiles a second template parameter that is the index type. So this vector uses only group index as the index. So if element is whatever it is, then the elements inside this one is just this element plus 1. So that's the context. And the other context is then, well, these values, or at least that one. Well, actually, all the groups that come before the whole tree. Well, because I want type safety for the index. Standard vector uses int as an index, and my experience has been that that is a bit error prone and confusing, especially confusing. At some point you just have no idea anymore what an int means. If it's a count or an index, and if it's an index into what. By using a separate type for every index into something that is specific. My code is much more robust. I really started to dislike standard vector and standard array by now, because it's really confusing. It's much better to use something that has its own index type. It is, by the way, just standard vector. That's violating the rule that you should not derive from standard vector. So my vector is just a standard vector, as you can see. But with a little bit added. I have an index type, and then I override the add and the square bracket operators. And I also introduce an I begin and an I end that returns the index type. So it's pretty minimal, but yeah, works flawlessly. Okay, what to do with this? Yeah, I want to generate a tree. I want to print it, I guess. Right? So let's add my print on. Oh man, I wrote so many things. I could write loads of articles on all the stuff that I did, but it's all on GitHub. So I kind of expect people to find it by themselves. And I have the feeling that that never happened, but would writing an article help? Hopefully my viewers will pick it up. Start using these ideas. I think. Group index is... Do I even have a group index? Probably not. I think group index is defined inside the header of group. Let's add the utils vector though. Yeah, group also defines element. And I'm sure that it already includes iOS forward. So this should be enough. I did commit today, 1 hour ago. So sorry, I have not committed for many days, but I did an hour ago. And pushed it. That we now have a lot of files, as you can see. Split it up. Okay. Yeah, how to do this? So I'm running here over all the possible partitions. We have a loop over all partitions, and then I guess from that I want to fill my tree. I want to use this to implement one of the fix me's, which is dividing my shader resources over descriptor sets. So the elements are shader resources and the groups are descriptor sets. But I have to admit I got lost a bit in the interestingness of the whole thing. I just like working on this problem. Hello, Emils. I have to think for a bit, guys. What is my approach here? How do I create this tree? In the end, I guess I have just a single tree object, and then that is going to include all the other stuff below it. It has a vector of trees. So I might as well begin with my first and only tree here. And then that tree is completely empty, and I must be able to print it. Let's call standard on standard chart. And then I want to see an empty tree. Isn't that a good start? That means I need to implement this print on, which means I need a tree.cxx, which always includes sys.h at the top. Come on. Followed by include the tree.h. And then I have to implement. No, it's not a binary tree. There's many branches. I want to implement this one, just this one. And I'm going to pretend that we only have the iOS forward. Include that, and then I want to print, well, a whole tree. That's not easy. Probably should print it as on multiple lines and not everything on one line. I think I cannot print to an O stream. I need a special objects. Well, this tree is so big, it's going to blow up quickly, very quickly. So we have 5 elements. We are going to end with, oh boy, I don't even know. I don't even have an idea how it looks like, but it's growing. It's growing. Oops, almost exponentially. I think it's going to become very broad at the bottom. And if the bottom is so broad that, well, then the line above it must be spread out more. I need a good way to display this. So something like we have a 0 and then a count. And then below that we have 0 with a count. And 1 with a count. And then below the 0 we get again, I mean this is branching. From here we can go to there or you can go to there. And on each of these nodes also are also trees. So this 0, 15, etc. Oh man, I think I'm going to print it all on one line because it's the formatting to not do that is too difficult. So we're just going to print opening thing and a closing thing. And then in between we are going to print I guess the group. So I print the elements. Yeah, well, if you print everything on one line, that might be come in handy. Just print the elements and then the group index, and then the count, and then the list of all the trees. Exactly in this order. let's run over what the thing was called, M3s or what? It didn't have any name at all. Let's call it children. Yeah, also I call it children. I might as well call this Charles. And then we append to the O stream the chart. We want it to be comma separated, so well, this gets us a little bit in the right direction. The only constructor you have is element and group. Okay, well, our element A is always in the group 0. I think I just need a group. I need a group element here. I also need A now. Do we have a GPS here or not? No GPS. And all the nonsense. What did I need? Element, right? Element index? No, group index. Basically, just the I begin on one of those arrays. If you ever can find that back, where do I have my groups? Let's see if I can find that. Nah, it's probably a stupid idea. I don't have a group, I just want to have a... I just want to have a group index that is 0, period. Otherwise I would need a partition. I don't want that. Groups. Okay, so this printed out that A in group 0 occurred 0 times. And then the equal sign is then followed by all the children, I guess, but there are no children. Equal sign is not really clear, is it? It's a better character. There is no cure for cancer. Yeah, well, okay. How do I fill this tree? Every time I get a new line, I would have to see that A equals 0, and therefore I want to increment this count here. Yeah, this A is directly corresponding to this A, so I might as well make a vector that contains all my trees. No, not all the trees. No, I need, what do I need? Okay, I can have, I think, a vector with, or an array even, with point for each element. We can have a pointer to the tree. I wouldn't know how yet. On the other hand, I begin here anyway. Begin here. Then I get a tree. Then I see the 0. I could tell the last tree, that's this tree, that I have a 0. I only need keep track of the last tree, as it were. So I need a single tree pointer, I think. Let's call it the current tree. I'm just, you know, hand waving here. My current tree is pointing to the tree here we have. Printing it is nonsensical yet, but at the end I want to print it. Now I'm going to run over all the partitions, and that calls print groups, but I have to expand that. I want to do the same thing as print groups, so inefficient. Oh, let's not call print groups. Let's just call. Let's just copy everything. Separate it so we know that this used to be print groups. So of P. So we really want to do p.m groups, which is of course not allowed, but let's start with filling it in. Yep. So whatever P is partition. I need a way to get to m groups. At least I need to get an I begin and an I end on it, and I need to access it by group. I need to get a group, iterators, and the group itself from an index. I can get a group by group index, and I have a begin and end, but it returns a partition iterator. I just want to run over the groups. I guess I can add the group iterator for that. So lazy type. Let's call this group begin. Which then returns m groups begin. And the group end returns m group end. So now I can run. Oh, I want I begin and I end. So now we can just call g begin and g end, like that. And I need to access it. And I forgot again how I did it, of course. It's not get group or something like that. Or, yeah, group index, it's just group. conversion from void to non-scalar type group index. Why is my G begin a void? Oh, because I don't have a return here. And that was group, not groups. Right. So this is now where we print these elements, and I have my element and the group value. And I think that what I need to do here is the first time I get here is when element I begin, which is actually the same thing as oh no, this is a group index, but it's more like this thing. Getting a headache, like literally. Country. Let me return to the drawing board. So this is printing it. So we start here. Obviously, we begin with group 0 and element A, and the current tree is pointing to the top, the very top here. So what I can do then is tell that tree to increment this number, which is currently 0, but it's going to 52. At the end it will be 52. All good and dandy. Then I print this one, and now I want to tell this tree to increment itself. And the next one this tree, and the next one this tree, and the next one this tree. And then we go to the beginning again, it must be again this tree. And then again da 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 da. And then here I want to increment this tree. I can get the tree from the previous tree with the value that I have. So for example, when I get here, we are in this tree. So increment this one by one. And then yeah, and then this one must increment index 0 on that. So exactly does that happen? Just need, I can pass it to the tree. That would be the easiest, I think. Pass it to the tree. So I pass 1 to the tree. I pass it to this tree. That would be here, and then this is the one that I pass. And it must also update the current tree then. So it must increment it and return. So it must be a function that updates the current tree and gets all the information it needs. Really? So we can do current tree becomes current tree. Update. And then we have to pass the information that we need. And the information is the group. Just that time in your life when you think that Roblox is the whole universe. I envy you. I think this is doing what I want. So we get deeper and deeper and deeper into the current tree. The current tree is updated, I mean, until we get to the end. And then when do I want to reset that again? I want to reset it at the beginning of the next partition. In other words, here. And then I need to write the update on tree passing a group index G. So this returns a tree pointer and it's called update. And it is not const, and we pass a G. And then it is going to get the tree. Let's call it the tree pointer. It's basically the next tree, which is really then m children, where we use g as the index. And I need a pointer to that. Now we need to return that. And I need to update it. No. Well, no. The first time, let me see. Damn it. I think I'm close, but it's confusing by one off. If I don't know. I felt that it was one way, but if you look at the startup, then the first time we get called here is with the tree that counts. The element must be A, right? And the group index is 0. This is already all set. I just want to increment the count. So you would think that the only thing I have to do here is plus m count. But yeah, it's nonsense. It is nonsense. Because what is being passed must be the group index of B. Otherwise, I can never return the tree, the right tree. So the first time is confusing. Yeah, I don't need a define. I use pragma once. Let's have a closer look at the first time that this is called. So we come here and we have this tree here, which maybe we shouldn't. But that's a tree for element A. And the current tree is set to that. And then we run over all elements. We begin. This is probably. Let's move this one down. And this runs over all elements. So we start at element A, and then here I just find the group where it is in, and for A that is always there. It's always the first one. And if I find it, I might as well break, by the way. Not going to find it anywhere else. So I'm calling this with the first tree, and I'm passing G, which is the group that this element is in, which is always the first group for the first time. So it doesn't really matter what I do. I increment it and I'm returning something. It must be a different tree. Feels like I need a dummy tree. Current tree. Well, like say current tree must be previous tree. It's nonsensical. Okay, let me close my eyes. Yes, think about this. It's stuck. Yeah, need dummy tree. Nobody wants a dummy tree. What if I do this? Cannot follow exactly what this is saying. Well, the shift is too large, but why is the shift so large? Yeah, in const expression, expansion of element 0. In const expression, element index 2-bit. Element index. So it is interpreted as a 0. I have no idea, man. I just try that like that. I mean, I can construct an element from elements type. Probably, maybe it took this one. But I was talking about this one, wasn't it? Element index is an elements type index, which is a bit set index. Okay, I don't know. Let's try it like this. That works too. 260. Something is wrong. Okay, so this is now being called on that first thing, which has an element. The first tree that we create, the only tree that we create so far, gets passed an element A. Therefore, M element is set to A. Therefore, this is false. Therefore, we do not do this. Therefore, we return simply the pointer to the current object. But we do increment the count. So in total, it calls this the number of times that that would be the number of elements times 5 times 52, 260. So that's totally expected and correct. However, the next call I want to do this. Cannot return the same object. I really need a dummy thing, a dummy tree. can hardly wrap my head around why that would be necessary. But I guess it is. There's no way around this. Yeah, I don't think so. I don't think so. Okay, then first element is no longer needed. We just do this always. And I'm constructing it with a default constructor. Well, you're going to need this one. But the dummy tree is constructed with the default constructor, which then sets, let's say, everything to the everything default constructor element as a default constructor. Does not have a default constructor. Cannot even make a dummy element. Sure. I can make this one undefined. That's something. Element must be initialized, and I don't know with how, but let's put it to A. It's not being used really. And then this one we set to undefined, which means that it is a dummy thing. And mcount is just undefined, literally. RGIA gaming, yes, tree is a node thing, yes, I guess. You mean I should put this in a node? Yeah, I probably am not approaching it correctly. So what would be the right approach here? Well, I'm just gonna go with the dummy for now because I don't see the light with. Okay, so when the current tree is equal to root, then I want to get back the actual tree. And the fun part is that does not exist. exist yet because the root is empty. So what I'm doing here is I'm calling update with G. Now I'm having the feeling that probably I should pass the element as well. I'm printing them out as EG, right? Let's pass it like this. Element comma group on update. Let me make C tags again. So then the problem here is that mchildren does not have G. So we have to create it. If G is larger than the size of mchildren, mchildren is a vector, capital V vector. So do something like I end. And it should never be larger, I think. It's just equal end. Then we have to create it. So we have to resize it and make it larger. I can just do a pushback, right? We are at the end. Just do a simple, do a resize or pushback. I have to do pushback. Children is, pushback or place back. I want to put into it a new tree. Let's do it and place back. And what we want to add is, well, I guess the element and the element that we have here, and then group, I guess. It's exactly what we pass. Well, let's see if it blows up. If it blows up, I'll have to run it in a debugger to start to understand what happens. Nothing blows up. Damn it. It's still 260. What? Okay. So I think this kind of gets close, right? For every time we start a new partition, we reset the current tree to the root. And inside this loop, I update current tree with whatever it returns. And then passing all the information I have. E and G. Can hardly be wrong, this. Therefore, I want my my debugging library to be linked. Is it already linked? I don't know. So far I've been using standard cout, but it starts to get, it is growing too far. So I want to have a real debugging library linked, which means that we have to find here the way to do that, because I don't know that from the top of my head. I just keep peeking at my own code to know how to do things. No, where's my test? This is how we do it. This is how we do it. And that requires this as well. Maybe that even. Yeah. I already have a debug here. Well, in that case, let's see if this links. What tree was not declared? I have to print root. Whoa, that links. Entering main. Also, we have some outputs. So the -1 is the root, and then we get A0 is 52. That's correct. Then the rest is not readable. So how about I do a new line after. How can I format this better so I can read it? I think every time after I see this equal sign, I could put a new line and an indentation. Okay, I never mastered the right way to do indentations, at least not without my debugging library. My debugging library is not really suited for multi-line output. Not really. Well, actually, I could do that, but it's a print on, right? So. I could peek how my debug library is doing it. Nah, we just need to print a number of spaces. Let's say I do a indentation equals 0. And then after this we print a new line. And I increment my indentation. That's not going to work. It's a recursive call to print all. Well, I guess I could make a custom O-stream manipulator that tells me what the indentation is. That's a lot of work again, but damn it, I want an indentation, and this is probably not the last time I'm gonna need it. Sounds like a good tool to have. Yeah, so I'm printing a new line here, and I'm incrementing the indentation then. So I need to link the indentation to the O stream somehow, which we can do by including utils. I guess it's called io manip.h, and if not, then maybe io with a lowercase. Also not, and then we have to look at utils. All lowercase, io manip. Yeah, I have to implement manipulator. I still don't know what the difference is between sticky and non-sticky. Probably should make it this also something in utils, so I can use it elsewhere as well. But let's first do it in this one file. Need it from the externally, probably not. Let's just copy this stuff. That would be my manipulator. And then how to use it. You just pass along to it, and then value of 0 is the default. It's returned when the manipulator wasn't used. So I guess this is the only thing I need here. I don't need an if, I just want to get the value. That would be this one, I guess. Size type character. Indentation spaces. And then everything has to be indented with the indentation. However, immediately after this equal sign, I want to increase the indentation. And the easiest way, I guess, is just to increment the indentation with 2 spaces like this. Lazy me. And I guess then this is the original indentation again, because it matches with that one. Actually, that's nonsensical what I'm doing here, because it's nonsensical at all, completely, total nonsense. Separator. I think I have to set if this is the new line here, so I need to set the separator to the indentation string. Now we start with the indentation and then we print commas and we end with that. But printing the child is recursive, so I need to increase the indentation somehow. If it is sticky, my feeling is that if it is sticky, I can just print it once and not inside the loop. Let's try that. Okay, I've got again now how to do this. IO manip. Just parentheses. So increase the indentation by 1 here. And then I guess I'll have to reset it to here. Yeah, if this works. It begins good, but then fail, I think. So this is the indentation, and then it starts to print this, and then the indentation is loads and loads larger than here. This is 2 spaces, what I want. And here I have 1, 2, 3, 4. Why is it indented 4? I guess this whole separator thing is nonsense. Yeah, we're printing recursively immediately. So separator should simply be empty at the beginning. So now we have an indentation of 2, 2, 2, 2, 2. And then, oh, this is not 2. Oh, that comes from here. It's printing an indentation after a comma. What? Yeah, it's of course, it's putting this indentation every time we start with an open brace. That's the beginning of the new element. Also here we print a new line and then the closing thing when it is empty. I don't want that. This must be indented as well, I think, so that it lines up with that one. Yeah. No, there's no indentation here. Indentation string. Now we have indeed indentations that work, and then we get closing brace at the correct place, and then a comma for the next element of yeah, so instead of this comma must be followed by a new line, I think. Let's try that. Note that this already looks good. 52, 15, 5, 2. 1. That's exactly correct. Then this one was 1. RGIA Gaming, nothing is going to take longer than my game engine. I doubt I'll get it finished, unfortunately. Well, I don't know. I already gave up, basically. I cannot finish it before I'm too old to write code. Not within 10 years, certainly not within 20 years. I mean, not within 20 years maybe, certainly not within 10, something like that. So, I mean, the rest of my life, it's more about having fun, right? I mean, you can't work and work and work and work and not have fun and then die. That makes no sense. So I like doing this, but that's the whole point. I must like it. I'm not trying to reach some goal or something like that. Just trying to have fun. And by the way, so these numbers are already pretty damn good, I think. Although I'm not sure if they're correct, but both of them look correct. So why not all of them? Okay, this is also sucky. And what happens here? Some indentation has not been really correct. I think this should also be, yeah, after closing brace that is not followed by a comma, we also need a new line. If you ask me, that's this one. Right, except that now my commas are in weird places. Yeah, I want those commas to be here. So that was not correct. I only should print a new line when it is not followed by a comma. And difficult. How to do that? How do we do that? So I just printed this, which ends on this thing, and then here we go to the top of the loop, and we print separator, which is a comma. Or we go to the top of the loop after having printed this, and then exit the loop. So more like that, but only if this thing was not empty. No, it looks nice. Very long, but nice. So I have here now a 5, and then a 10, and another 10, and another 10, and then 17. And that's what I did here manually. 5, 10, 10, 10, 17. Guys, it's just working. It is working. So now I'm printing this tree. And the next step is then that I look at these numbers and then come up with the structure. The problem is that it is taking so many lines that I can hardly look at it and think, okay, I have a very expensive headphone and it is starting to drop out on one side. I broke the cable before and then I fix it. I think that at some point I have to replace this cable. And it's going to be very expensive, unfortunately. Really? Why is it dropping out? I don't know. Playing a bit with the cable, but nothing. I want to go to a larger number of elements. Oh wait, there's no defined in element.h. I could go to 6, I guess. 7 even. Let's try 6 first. Okay, 8. Well, it's using too many lines. Definitely too many lines. $14,733 lines. No. There's probably a lot of them already. Nope. Oh, I thought I went 1,000 down and then 500 up, and then 300 up, and then 200 up, and I'm not there yet. 1, 2, 3, 1,000 up. 1, 2, 3, 1,000 up. I think that I went accidentally 10,000 down. There we are, 500 down, 100, 200 up, 200 up, 100 up, 50 down. Now we are there. Could have used a regular expression, I finally realized. I didn't think it would take this long. Well, I recognize the 203, so I guess the 877 and the 4140 are also totally predictable. As in, they are here. Yep. 877, 414, okay. But the rest might not be as easy. Well, this is always going to be 1, 1. Always. Just know it. And then this one is 3, followed by 1, 1, 1. And we have again 10 here. So below the 5 we have a 10. That was the last time also the case. Wouldn't it be nice if this looked exactly the same as the other one? So 10. So we have 5, 10, 10, 10, 17. See, so it does totally not matter. Well, we are still on the edge, of course. Now we get a repeat, and then you don't know what happens. But I'm pretty sure that this part of the tree is equal to the smaller tree. So that's nice. Now, previously we had nothing after the 17, right? Because it just stopped there. Oh, I overwrote it. Oh no, I overwrote my my documentation. Oh well. So we had 5, 10, 10, 10, 17. And now we have, after the 17, that would be the F. we get 10 again. Okay, I have an idea. I'm going to grab this file for just A. Was it A colon? No. It is hashtag something. Now ignoring the root. Let's always ignore the root, right? Well, it's not going to turn up when I look for something else than A. So this this 4140 can be gotten from this table here. That was an easy one. Then the B looks like 877 and then 414 minus 877. So if you know this one, we also know B. I mean, the 877 is just the next number here on the table, and that this holds for any number of elements. So we already know A and we know B. As if we put this table in it, or I can also calculate this, but it's small enough for a table. Now the C. Wow, 3 times the same number. That's interesting. That is very interesting. So the 203 is this number. And then we get 3 times the same number. If that's always the case, then the only thing we have to do is figure out why it is 674. And then the last one is simply again 3,263 minus 203 minus 3 times 674. 74, yeah. Correct? Yes, of course. And still I'm typing it in. I don't know why. 3263 minus 203 minus 3 times 674. Nope, there's 1038. That's impossible. Let's add them up. 1915 plus 3 times 674 plus 203. Oh, that's 4,140. So these add up all again to this. Okay. Why do we get 3 times the same number? We don't know. Okay, where does this 674 come from, do you think? Nothing super obvious. Let's look at the D. Not as beautiful at all. There must be a pattern in it. Absolutely sure of it. But what is it? Let's try a few things. Well, I see some pattern. If it is 0, it has a certain value, and then the next one is the same. And then the last one in the series, I mean there is no E is 3 here, is different. So also here we have 77, 77, 77 for 0, 1 and 2, and then the last one is different. And then if we have in total 4 things, it looks exactly the same, no matter what the value, no matter where we are. So if it runs from 0 to 3, it ends on 144. In other words, every E3 has 144. In other words, it starts with 15, but after that every 0 has 37. Yes, so we can, for example, search for just this number, and then I was wrong. What? Okay, that sucks. Oh, there's even a 100. Okay, wait. They're all the same. Sorry, they are all the same. So that's not true what I said. It depends on the last value. So I should ignore this one if there is an E3. Or if there is an E4, I should only look at E4 and E3, but E4 is not interesting. So it should only print the ones that are one before the last one. Everything before it is the same. So and after it is just some value minus these 3. Let's see if we can figure out what that value is. For example, this one. That would give a certain sum. So 3 times 77 plus 141, so 372. Saw that before. I think that was just equal to these things. So that's up in the tree. So it should be easy to find what the last value is. Where does this come from? The 674. I think what we can do is just make a sequence of, let's say, we already know what this is. Even if though the actual series goes the other way around. I can do that for the second number as well, and then maybe you can find it in the integer sequence database. What that is. Something like that. Let me look at the next one. F. Clearly these are all every time the same value, and they are equal to the previous top value minus this top value. So 203 minus 52 is 151. Let's repeat it here. 52 minus 15 is 37. 15 minus 5 is 10. 5 minus 2 is 3. And 2 minus 1 is 1. So all these numbers can be analyzed already. And then the big question is then, well, if this is 151, how often does that repeat? For example, if I take the D, and I print more of them, see that it repeats 3 times. Why does it repeat 3 times? Oh, sorry, it does not repeat 3 times, it repeats 2 times. 0, 1 here, and 1 here. Okay, we also knew the total sum of these 3, right? $151 times 2 plus 372. 674. Yeah, that was this value. Yeah, this is just recursive. Not sure if that's helping me. Probably should be helping me if I do it one by one. Yeah, let's look for the number of times they repeat. That means that I want to know B, I know. Let's just start with the C. So I'm looking for C0. And then the one before that. That's nothing. C does not repeat. C does repeat. I have to do this one first, sorry. So I do this and then I grab for this. And then, yeah, I also need the last one. Ah. Okay, so C goes to 1 and then to 2. No, I'm not sure this is what I was looking for. But then again, maybe it is. Let's have a look at it, just the pure output. So I see here 1, 2, 2, 3. So it goes to 1, then we go to 2, then we go to 2, then we go to 2, and then we go to 3. Yeah, so I just have to probably just have to ignore the minuses as well. Okay. That looks like a random noise. 1, 2, 2, 2, 3, 2, 2, 3, 2, 2, 3, 3, 3, 3, 4. Horrible. Nope, okay, that's not working. Guess we just have to be smart. That is, think about it for a long time and then give up. Probably. Hmm. Yeah, I think I have an idea for a next step. I'm just going to look at B and how often that repeats. That's a single number, so we can look it up in the database. Already have that one, damn it. Is there a direct formula for this? What I'm doing here is if I want to know this number, we have element.h. So I have 8, and the larger that number is, the larger this value gets, of course. If I make this a 9, then we go to the next number in this series. Yeah, well, okay. As simple as that. So there would be 1, 2, 3, 4, 5, 6, 7, 8. So it's just simply add this series and then n minus 1. Well, A is the same series, but then for n. So after 4140 we get this number. So this is just, yeah, okay, worked out. No, I have to concentrate on C. C is more difficult. We know this number, it's just going backwards. So this is now n minus 2, aka 9 minus 2 is 7. Well, this is 1, 2, 3, 4, 5, 6, 7. That's 8, 7, 7. That's that first number. And the shitty thing is I already know what this number is. That's that number minus this number. Actually, the whole C is also known already. Yeah, C also known if I go even further up. Let's go to 10. Yeah. So this is simply sequence n minus 2, and this is the sequence n minus 1 minus the sequence n minus 2. And that is repeated 3 times, and then we get the sequence n minus everything above it. So C is already completely determined. But that is because C is always doing 0, 1 and then 0, 1, 2. And that is because the 0, 1 is done while B is 0, and the 0, 1, 2 is done while B is 1. Aha! So this sum must be equal to the number of times that b equals 1. That's funny though. So these two together must be equal to this, and these three together must be equal to that. While this value is the same as that one. Let me just check that anyway. 2 times 17007 plus 60814 is 94828. Yes. Now it would be very nice if I could, with just this number, find this sequence, which I could do if I knew how to get this number quickly. Unfortunately, that number is just the difference between two values from our sequence. It's not entirely clear why, but no matter what I do, C is exactly determined, so I'll have to go to D. Okay, so this is a number from the sequence, and the sum must be equal to this number, which is a number from the sequence. So this is a difference from the sequence, from two elements of the sequence, and this one is the same. And then this one, these three added up must be equal to the corresponding value of C, which is 17,007. It's pretty much doing the same thing. Yeah, it's all totally recursive, hanging together. But, okay, how does D work further? Then next we get the same thing, because this repeats 3 times, so D repeats 3 times as well. 1, 2, 3. And then 1 time with that one. Ah! Right. Starting to see the light. Yeah. 0, 0. Yep, that makes sense. Let me try E. say if you analyze this as how often does the same sequence repeat. So we have here 0, 1, and then we get 0, 1, 2. Therefore the 0, 1 repeats only one time. So I type in 1. And then we get 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 3. So 0, 1, 2 repeats 3 times. And then we get 0, 1, 2, 3 one time. And then we get 0, 1, 2, 0, 1, 2 2 times. And then we get 0, 1, 2, 0, 1, 2, 3 one time. And then 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 3, oops, 0, 1, 2, lost it here. This is 1. Then we get this 0, 1, 2, 2 times. So I have a 1 and a 2. Oh, where was I? So it's 1, 3, 1, 2, 1, 2. 1, 3, 1, 2. 1, 2, 1. No, not 1. 2. In other words, I lost it again. Repeats again. Let me try it again. Why is this longer than my... Sorry guys, it's my memory is too bad. I have to go to a small font just for a bit so it fits on my screen. Even this doesn't fit. Oh, this just fits. So now I can see this as well. 1, and then we get 1, 2, 3. And then I get this 1, and then I get 1, 2, and then I get again 1, and then we get 1, 2, and then we get, that was that 2. Then I get 1, 2, 3, 4. Really? So 4 and then 1. Thought I saw some pattern. Must be there, of course, but... Okay, I don't know. Well, we can try our luck, I guess, and do the cumulative sum, and then see if we can find that in the sequence database. But I don't know. How do you print a cumulative sum? Yes, I am. Hmm. It's not that advanced. Well, maybe it's a difficult problem, that's for sure, but the C++ itself is not really advanced. I have other code that looks like Chinese in terms of syntax. I'm printing it like this. How am I printing it even? Just print the root and then we print all the elements one by one. Artem, that's exactly what I wonder myself. I have no idea why people find this interesting, but every time I ask, I get the feeling that many people just like the sphere, they just chill with it as if it is music or something like that. Maybe as a background thing. I mean, if you're from America, isn't it in America the custom that you have your TV on all the time, non-stop, the whole day through, with sound on, even though you don't watch? Well, then this is very relaxing. If it causes you to turn your TV off, and most of the time I'm not saying something, well, that's maybe an exaggeration, but I do not even own a television, let alone that I have it on the whole day. It's silent here. Yeah, as I said, he switched to HD because my experience is that if you start watching the stream, often YouTube doesn't even switch to HD, and until it does, it's unreadable, the text. It's super unsharp. So then you have to manually tell it to, I want HD, damn it. And then you get a more or less sharp, a sharp image. Okay, I think I don't make any progress at the moment, so I'm going to stop and then I'll just think it over off stream for a long time. Because watching me being stuck and doing nothing because I don't know what to do, that's really boring. So I was hoping to be able to generate a number, a random number between, let's say, 0 and one of these numbers, and then go directly from that index to the partition. These are the lists of, say, the number of ways to partition a set of n labeled elements. So this is the number of partitions. What I want to generate a number from 0 to this number, and then immediately go to the partition that belongs to that. And I'm sure it's easy. I mean, there must be mathematicians that shake this out of their sleeve easily. But for me, it's just a puzzle. So far, I must say it's totally possible that I won't do it, because it's just going to take too much time. I'm sure if I put half a year in this, I would solve it. I mean, it's solvable, so it can be solved. Therefore, I would solve it. But it's definitely not worth half a year of my life. Other things to do. So at some point I just should give up, I guess, and then return to the previous problem. But I'm very bad at giving up. I'm like, damn it, I want this to solve this. Okay, I'm going to do something else now. So, good night. I'll see you next time. The MLG Legend asks, wouldn't you consider discussing it with people that do the same thing? Well, I wish I knew people that were interested in discussing this. How many people on the street would want to discuss this with me? I bored my parents with it when I visited them. I was talking about it just because I needed someone to talk to about this, and I can talk to you guys about it. That's what I'm doing, more or less. But yeah, when I was on the university, sometimes I could talk about an interesting problem with another student, although even that didn't happen that often. But I'm trying to get friends here. I mean, I'm living here now for 4 years, and I still basically don't know anyone. Partly because I don't go to clubs, I just sit behind my PC. But I would like to have, someone physical in my life. I don't want to be all alone. So I'm trying to get anyone, literally anyone, to go and drink a cup of coffee with me somewhere. Now, I found a woman, and she says she's 67. And she's interested. So I'm going to drink a cup of coffee with her. Okay, now, question to you. How big is the chance that we sit there at the terrace with a cup of coffee? How big is the chance that she wants to listen to my mathematical problem? I think near 0. And if you take almost anyone else from this neighborhood, there's two possibilities. Either they have no interest because they don't understand it. That's most of them. Or, and that's because I do live in the neighborhood of ASML, and they hire smart people. So there are a lot of smart people living here in the neighborhood, but they don't have any time. No, during the day they work, and then at night they have to do the households, and then they drop in bed exhausted, and they're not interested to talk about mathematics with me in the free time. So yeah. Okay, well, anyway, I'll see you tomorrow then.